Alright, peeps, talking about square root functions, day 2. So we're going to talk about transformations. We're really going to hit transformations today. Alright, going from our parent function is the square root of x. We talked about this yesterday. What we want to do is we want to look at perfect squares. Okay, we want to look at perfect squares. So what I'm going to do is I'm going to start with 0. So when x is 0, we're going to take the square root of 0, and we get, obviously, y is going to be 0. So we know that the first point is at 0, 0. Alright, now 1 square root of 1 is a perfect square, right? So I've got a point at 1, 1. Now I'm going to jump to 4 because I want, again, perfect squares, right? I want these numbers to be nice and neat. Okay, well the square root of 4 is the next perfect square, which is at 2. So if I go over 1, 2, 3, 4, I have a y value of 2. Now I'm going to jump to 9 because 9 is my next perfect square. The square root of 9 is 3. So I've got a point at 9, 3, and your graph looks like that. Alright, so let's talk about our key attributes here. So key attributes, domain. The domain is going to start at 0, and it's going to go to infinity. So we can say that x is greater than or equal to 0. We're going to write it as an inequality. Can I find a pencil that works? So I've got x is greater than or equal to 0. Now the range is the y values. The range starts at 0 and also goes to infinity. So we say y is greater than or equal to 0. My vertex is at 0, 0. Okay, and then is that a minimum or is that a maximum? That's the lowest point on the graph, so that is a minimum. Now let's talk about some transformations to the graph. So if I change, let's look at our square root function. So I've got y equals a x minus h, x minus h plus k. Okay, now I could say, let me erase this. I could say inside of my parentheses, if I have a number inside of my parentheses, we're going to call that b. So b times x minus h plus k. All right. Now, a change to the sign of the a value. Change to the sign of the a value is a reflection. Change to the sign of the a value is a reflection. Now, if I'm just looking at this number, and if this number is greater than 1, it is a vertical stretch. And we're going to say by factor of a. Okay, now, this has a value of 1. The parent function has an a value of 1. If it goes bigger than 1, if a is bigger than 1, it's a vertical stretch by whatever that number is. It's that number times whatever my stretch was to get that number. If it's less than 1, it is a vertical compression. Again, by a factor of a. H, the number inside of the parentheses, we know is a horizontal shift. Now again, anything inside of the parentheses, anything inside of the parentheses is going to move it right or left, opposite of whatever that is. Okay, a k, which is the number after, is a vertical translation. So we're going to move the graph up or down. Now the b value, is a horizontal reflection. So this is a horizontal reflection. If b is greater than 1, it is a horizontal compression. By a factor of 1 over b. So this is the exact opposite of this, right? If a, the number outside, is greater than 1, it's a vertical stretch. If the number inside of the square root is greater than 1, it's a compression, a horizontal compression. By a factor of 1 over b. Okay, this would be a horizontal stretch by a factor of 1 over b. Alright, so let's look at our key attributes here. My domain, my domain is still going to be x is greater than. But now, again, when we're looking for the domain, all I care about is the x values. Well, this thing moves it right or left. So it's x is greater than or equal to whatever that value is. The range, in the same respect, the range is going to be y is greater than or equal to whatever value this is. Okay. All right, so let's look at example number 2. Now, example number 2, we can look at our parent function, 1 square root of x. What changed? We have a 2 outside now, and we have a plus 3 inside the parentheses. So we know, just judging by my equation right here, I know I have a vertical stretch by a factor of 2, and I have a horizontal shift by 3. And we know that we're going opposite of a positive 3, so we're going left 3 units. So if I was to graph this vertex, we know that we went left 3 units. So the k value didn't change, so my vertex is going to be at negative 3, 0. Okay, we know right now the vertex is at negative 3, 0. Now, is that a maximum or minimum? Based on my equation, it's a positive, so therefore, it would have to be a minimum. All right, now let's plot our points. So let's start at negative 3, since we know that that is the vertex. Negative 3, we plug that in, we've got 2 times the square root of negative 3 plus 3. Well, inside that's a 0. Square root of 0 is 0. 2 times 0 is 0. That's how I got that point. All right, let's plug in negative 2. So we go 2 square root of negative 2 plus 3. That's going to give me a positive 1. Square root of positive 1 is 1. Times 2 is 2. So we know we have a point at negative 2, positive 2. If I plug in a positive 1, I've got 2 times 1 plus 3, so this is 4. Square root of 4 is 2. 2 times 2 is 4. So positive 1, we've got 1, 2, 3, 4. Okay, and again, I'm choosing numbers that are going to give me nice, neat answers here. 2 times 6 plus 3. 6 plus 3 is going to be 9 here. So square root of 9 is 3. 2 times 3 is 6. So at 6, 6. So my graph looks like that. Okay, now again, what we're looking for is we're looking for perfect squares, right? We're looking for perfect squares when we're going to input. Now, going back to my domain is going to be x is greater than or equal to h. So x is greater than or equal to negative 3, because the h value is a negative, opposite, negative 3. Range is going to be y is greater than or equal to k. Well, k is still 0. Transformations, what took place? We already said it. It's got a vertical stretch by a factor of 2. And it's got a horizontal shift left 3. All right. All right, looking at our next example, we can see that we have some transformations here. We can see that we have a change outside the radical. We have a change to the b value, and we have a horizontal, actually it'd be a vertical shift because it's outside of the radical. All right, so let's look at our table here. So we're going to input 0 because 0 is going to be a perfect square. So we've got negative 1/2 times 0 and then plus 2. Well, 0 is 0 plus 2 is 2. So we have a point at 0, 2. We know that that's going to be the vertex. It's a negative. That's going to make it flip upside down, meaning that my vertex is going to be the maximum. Now, going back to my domain is x is greater than or equal to h, which in this case h is 0. K value is going to be a positive 2, so y is greater than or equal to, less than or equal to 2. Now, why is it less than? Okay, that puppy flips it upside down. So y is less than or equal to 2. All right, here we go. Let's find our next perfect square. We're going to plug in 2 because that's going to give me 1 underneath the radical. So negative square root of 1/2 times 2. 1 plus 2, so negative. I'm going to get a positive 1 because negative 1 plus 2 is positive 1. So if I go over to 2, I've got a point at 1. Let's plug in 8 because 1/2 of 8 is going to give me 4. 4 is a perfect square, so negative square root of 1/2 times 8. Negative 4 plus 2 is going to give me a negative 2. So at 8, we have a point at negative 2. I'm sorry, not my fault. Okay, Coach Sapp. So this is going to give me a square root of 4, which the square root of 4 is 2. So negative 2 plus 2 is going to give me 0. All right, so we have a point at negative 8, 0. That sounds better. Okay, and then if we plug in 18, 1/2 of 18 is going to give me 9. So the square root of 9 is going to be 3. Negative 3 plus 2 is going to give me a negative 1. Okay, so that's going to be way over here. So my graph's going to look like this. Transformations that took place, we had a vertical reflection. Okay, vertical reflection because of this sign outside the radical. We had a vertical shift up, so translation up 2 units because of that puppy right there. And then we had a horizontal stretch by factor of 2 because it's 1 over b. Well, b is 1/2, so 1 over 1/2 is 2. So a horizontal stretch, again, that's the opposite, right? That's the opposite inside of the radical. All right, let's go to number 4, or the next example. All right, so again, what we're going to do is we're going to look at our table. So let's plug in 0. We know that we're still going to get 0. Let's plug in negative 1/2 because that's going to give me a positive 1 underneath the radical. So at negative 1/2, we have a point at positive 1. All right, at negative 2, we're going to get positive 4 underneath the radical, which is going to give me positive 2. Okay, and then at negative 8, we're going to get a positive 16 underneath the radical, which is going to be positive 4. So my graph looks like that right there. Now, vertex still at 0, 0. My h value is 0. My k value is 0. So we know that my domain is now going to be x is less than or equal to 0. X is less than or equal to 0. My range is going to be y is greater than or equal to k, which again is 0. Is that a minimum or maximum? You know it's a minimum because the sign outside is positive. Transformations that took place. We had a horizontal reflection. Okay, and we also had a horizontal compression by a factor of 1/2. Again, we're going 1 over that unit right there. Okay, this negative inside is a horizontal reflection. Okay, and then the horizontal compression is that number right there. So let's look at our reflections here. Y equals the square root of x. That puppy looks like that right there. Okay, that's the parent function. That's the parent function. All right, so I'm going to label that y equals square root of x. Now, if we have a negative square root of x, a negative square root of x is going to make it open downward. So that is a reflection over the x-axis. Okay, reflection over the x-axis. And we would say this is a vertical reflection over x-axis. Now the negative inside, we just saw the negative inside is going to reflect it horizontally. So it looks like this. So we'd say that is a horizontal reflection. It's a horizontal reflection, so this is y equals, and that puppy right there is a negative, negative. Right? So with a negative, we take our parent function, the negative flips it upside down, and then we horizontally reflect it over the y-axis. Okay, so a negative outside, reflection over the x-axis, a negative inside, reflection over the y-axis. Bada bing, bada boom.